The goal of this video is to teach you how to record audio and to deliver this information in the least amount of time as I can. I will not go into too much detail in this video because there are other videos on this channel that have already been made on specific topics or that I will make in future videos to accompany it. Annotation video links will appear on screen whenever there is more information available on a certain topic, so let's get started. If you're just getting into audio recording, big warning to you. You'll be dealing with a lot of cables. A cable consists of three main parts: the shielding, which we see on the outside of the cable, the conductor, which is the internal wiring, and the connector, which are on both ends of every cable. There are a large variety of connectors and cable types. I'll be talking about the most common ones that you'll run into. First up, XLR. It's the most commonly used professional level audio connector. It's a three-prong connector that allows for balanced audio, which has less noise than cables with unbalanced connectors. There are two XLR cable types: the standard twisted conductor pair and quad, also known as star quad. Quad XLR cables have less noise problems, but at the cost of reduced high frequencies if your cable is longer than about 150 feet. It's a good trade-off because electronic noise is one of the biggest issues you'll deal with when making audio recordings. Also, most home studios don't use anywhere near 150 feet per cable. 25 to 50 feet is typical. The only problem is quad cables are more expensive than the standard two-conductor XLR cables. So my suggestion would be to buy a couple of standard XLR cables first and see how it works in your studio. Are there any major noise problems? If there are, get yourself some star quad cables. If not, save some money and get the standard XLR cables. The female end of an XLR cable, labeled in product catalogs as XLR-F, has a locking mechanism that must be pressed in upon disconnection. The female end is where you plug into devices' outputs, so a microphone, a DirectBox output, a mixing board output, etc., etc. Some XLR plugs do have a locking mechanism on the male end as well, but that's not always the case. A male XLR connector is labeled as XLR-M. The 1/4-inch TS connector is also very common in professional level audio. Sometimes people call it a phone plug because it was originally implemented for telephone board operators to patch calls between people back in the 30s, 40s, maybe even 50s. I don't know. I wasn't alive back then. But you know, the switchboard operators. It features a tip and a sleeve connector. That's what TS means. You may come across what's called instrument cable. It's the same as 1/4-inch TS cable. The main difference is that instrument cables tend to have purer copper and better shielding. The shorter the instrument cable that you use while recording, the better. I personally have two nice quality George L's and Mogami Platinum cables that are less than 15 feet long. They may not make a huge difference in overall quality, but I have peace of mind knowing that I'm not losing any quality by not using them. The problem with tip sleeve cables is that they're unbalanced and therefore more susceptible to noise by design. That's where tip ring sleeve, aka TRS cables, come in. TRS cables in the 1/4-inch variety add the ability to have a balanced connection, like XLR cables. It's the same connector that headphones use because you can also send two unbalanced channels of audio through a TRS connector. If you have a balanced input or output, then you should use TRS cables. They also enable use of patch cables for hardware inserts, which I'll get to later. Avoid 1/8-inch TRS cables whenever possible. These are less common with professional gear because they do not lock into place as well as 1/4-inch and XLR connectors. They're also more susceptible to breaking. Consumer headphones mostly use 1/8-inch TRS connectors. Professional level headphones usually come with an 1/8-inch TRS to 1/4-inch TRS adapter. The connector for speaker cable is exactly the same as a TS cable. The difference is in the cable wiring. Speaker cable is unshielded but heavy duty. It's able to handle strong power currents that an amplifier can put out to a passive speaker. And by passive, I mean it isn't self-powered. It doesn't have a power amplifier built in. Speaker cable allows you to put a guitar amp in the control room and have the speaker cabinet in a separate recording room. This makes it easier to hear exactly what is being recorded. It also makes guitar amplifier settings adjustments much faster. And it saves everyone's eardrums from being unnecessarily destroyed. Speak-On, or Speak-On, I don't know how to pronounce that, is another speaker cable connector that has a locking feature. If your speaker system supports it, take advantage of Speak-On. Never use a regular 1/4-inch cable for a speaker, and don't use a speaker cable for regular 1/4-inch or instrument connections. You'll possibly melt your cables with the former and have a lot of noise problems with the latter. Next up is the RCA connector, also called phono. It's mostly used in old school consumer video and audio gear hookups, before HDMI became the standard single connector for everything. RCA connectors are unbalanced. You'll see these with digital coax, also known as SPDIF connections as well. A digital coaxial cable is basically just a high quality 75 ohm video cable. So if you already have a good quality video cable, you can use it for those purposes. Acoustic Research is the brand that I've used over the years, and they have never given me any problems. But if you want to be on the safe side, buy a cable that's specifically labeled digital coax. Banana connectors are less common, but you may run into them one day, so it's good to know that they exist. One of the earliest digital connection standards, MIDI, is a subject unto itself. So I'll keep things brief here. Basically, MIDI is data that is sent for note sequencing. If you use a keyboard, then you'll more than likely need a MIDI cable. Although newer keyboards have USB outputs, you may eventually run into someone with an older keyboard with MIDI outputs only. If your interface doesn't have a MIDI input, then I suggest the iConnectivity Mio USB to MIDI interface. Other brands exist, but this one in particular has the best reviews and the least amount of reported complaints and problems. Next up is the BNC cable. It's a locking cable. You'll most commonly see this with word clock inputs and outputs on different audio interfaces. Word clock is the way that audio devices synchronize together so that they're sample accurate. The shorter the cable length, the better. BNC cables can also carry audio signals. They're basically higher quality RCA cables. Another digital cable that you may run into is optical, also known as Toslink. They're mostly used to expand audio interfaces and to connect them for synchronization purposes. It uses a fiber optic cable to carry data. It's preferred over using analog connectors between equipment because with analog you lose quality. ADAT, light pipe, and SPDIF are the common formats that these cables support. Wireless audio, meaning no cable at all, is also an option, but typically it's not used in studios because the connection reliability and audio quality isn't as good as a cable. The old joke in the audio industry is that a $5 cable is equal in quality to a $2,000 wireless audio interface. Now let's talk about microphones. There are a few different types of microphones. We have our dynamic microphones, we have our condenser microphones, tube condensers that require their own power supply, and we have ribbon microphones, which is a type of dynamic microphone. If you have a ribbon microphone, do not send phantom power through it, or you may damage it. There is an exception, and that's if you have an active ribbon microphone. Those require phantom power, just like condenser microphones. So obviously they can't be damaged, unlike your standard ribbon microphone. A subcategory of microphones is the lav variety, short for lavalier and also called a lapel mic. These are tiny microphones that are used on TV shows and films. They're typically used when a boom microphone isn't practical. On film sets, they're often hidden underneath wardrobe or in nearby props and furniture. Lavalier clips are very easy to break, so be careful and have extra clips on hand for when things go bad. Lavalier microphones are typically not used in music studios, so that's all I'm going to say about them in this video. As I said earlier, each microphone has its purpose. The reason being falls to frequency response, pickup pattern, and practicality. Dynamic microphones can be abused a lot more than condensers, for example. They also don't require phantom power. Condenser microphones, on the other hand, are a lot more fragile. They can be damaged from moisture, humidity, dust, etc., etc. You have to baby them. Dynamic mics are basically built like tanks. Now, they can certainly be damaged beyond repair, but not as easily. Condenser mics typically have a higher output level than dynamic microphones, and this is a good and bad thing. It's good for when you need to record quiet instruments. It's bad for when you need to record loud instruments. That's why condenser microphones often have a built-in attenuation pad, which I'll get to later. Ribbon microphones are the most delicate of all microphones, even more so than condensers. However, newer designs have improved their durability.